The next section on monitoring and diagnosing networks has a really brief discussion on two particular elements. Network monitors used to be hardware devices that you would insert into your network. You would just plug them in either to the coax line or into your UTP. They were devices that operated in promiscuous mode. They would pick up any traffic that went on the wire and then normally record that to a hard drive of some sort. These days you can do the same thing with any network card and a network monitor program. Microsoft has one. It's called NetMon. It's free. You can download it, and there are several other packages that you can use. Again, and this is true with almost anything that you're going to do, a software-based utility is going to give worse performance than a hardware-based utility. That's just like a server functioning as a router is going to perform worse than a dedicated hardware device for that. So if you are big into network monitors for some reason, you'll probably want to look at a hardware version of this. The other component that they discuss are intrusion detection systems. These can be hardware-based or software-based. And if you look at the diagram on figure 3.11, you'll see that we've got a hierarchy here. From the internet, the first device that traffic encounters is a router. Then you've got a firewall. Then you would have an intrusion detection system, and following that you would have access to the rest of your network. Intrusion detection systems are actually pretty complicated because they will monitor traffic not so much the way that firewalls do, but they will keep track of what's going on in your network, and if they see something unusual, they can disable services, they can segment networks, they can do all sorts of different things. The last paragraph of this section on intrusion detection systems tells you that it can react by disabling systems, ending sessions, and even potentially shutting down your network. Larger environments or very high security environments are going to have something like this in place. It's kind of like a performance monitor in a way. When you set up performance monitoring, you're going to set certain thresholds, and if these thresholds are exceeded, then some sort of a notice is generated. In terms of an intrusion detection system, if there's something abnormal, different traffic patterns or high levels of activity, it's going to respond by usually notifying somebody and then taking some corrective action. Now that we've covered the common hardware components, we're going to switch gears and look at securing workstations and servers. And a lot of times this is going to be done through software. The book makes a really good point. In a typical network, you're going to have a handful of servers and a whole lot more workstations. And so the odds are that a workstation is going to be compromised before a server is compromised. The book stresses that you should keep up with security fixes and that sort of thing, remove unused software, services, and processes. And these are all good ideas, but it's kind of hard to tell what is an unneeded or unused service. That's one thing that just irritates me, because you always see that recommendation. But then in terms of actually giving you guidance to determine what do I want to turn off, they don't have a whole lot of information there. The book has a good suggestion that just looking at whatever your operating system is, doing a Google search on that OS and the term hardening is going to give you a lot of guidance there. I know that in terms of workstations, one of the suggestions the book has is turn off the server service. And you can also disable file and print sharing if you are not going to be sharing anything off of that box. There's a tip. The book mentions that one way to make sure that you have secure workstations is to lock the configuration settings on the workstations. And you can do this through group policy. And I think this is an excellent idea. Group policies are applied either at login or when the box boots up, depending on the type of policy. It will put the same configuration on every workstation that you choose, and it can enforce things like it can prevent you from browsing the C drive. It can prevent you from using floppy drives or inserting USB devices. Obviously, you'd have to figure out what your users need to do in order to be productive, but you can take a lot of steps with group policies. You can ensure that those are applied every single time. The real-world scenario discusses users installing unauthorized software. And this is a double-edged sword. If you've got users who are reasonably computer literate and are trustworthy, then it's not a big deal to give them administrative privileges so that they can install printers or install software. On the other hand, if you give people administrative permissions, they can install anything they want to. They can download software, and who knows what they're going to end up with. You know, the downside to restricting permissions is that you have to take some action if you want to install software for somebody. And I've got a client right now that wants to install a webcam, but he doesn't have administrative permissions to do that, and so I've got to remote in and take care of that for him. There's a section in the chapter about understanding mobile devices, and I really don't know why they've got this in here. They discuss mobile devices in Chapter 4, and it seems like they refer you to Chapter 4 rather than really give any information here. The next topic of interest is understanding remote access, and this is something that you will be configuring when you're managing a network. The first box here says Ancient History, the Serial Line Internet Protocol. Okay, well, I remember configuring that, so I guess that means I'm ancient. There are different protocols that you can use to connect, and the rule of thumb is the same as it is with any protocol. The simpler it is, the less secure it is, but the faster it is. So SLIP is, there's no security with that, but it's pretty fast. Point-to-point is also pretty fast, but it's not terribly secure. There's a brief discussion of this. Most people don't use that anymore. You want to use a tunneling protocol, and that is going to give you endpoint to endpoint security and also encapsulation. There are several different tunneling protocols you use. Point-to-point tunneling protocol is PPTP. It encapsulates and encrypts your packets. Layer 2 forwarding, it says, was created by Cisco, and then the Layer 2 tunneling protocol, L2TP, is commonly used these days. That was a joint venture between Microsoft and Cisco. You'll see that all of these protocols use different ports, and they will use TCP and UDP for their connectivity. So if you are using these, you need to make sure that your firewall or whatever devices you have in place for security leave that port and that protocol open so that you can have inbound traffic there. IPsec isn't a tunneling protocol, but it can be used in conjunction with tunneling protocols. There's a real quick blurb on the wireless protocols, 802.1x. There are a whole bunch of different flavors of the wireless protocols, and they refer you to Chapter 4. The next section talks about radius servers, and people who have a lot of remote connections will often deploy a radius server. It says Remote Authentication Dial-In User Service. Just because it has dial-in in the name doesn't necessarily mean that it's restricted to dial-in. You can use this for any kind of incoming traffic. Essentially, this is going to be a server that authenticates users that are coming in remotely. TACACS, discussed on the next page, is another alternative to Radius. The two of these technologies, both of them work with authentication of remote users. The next section in the book deals with securing internet connections. It talks specifically about working with ports and sockets. I know that we covered this earlier in the semester, so this particular part can be reviewed. When you're using TCP or UDP, those two protocols, most of your communication for different functions is going to occur on a specific port. We've seen several different lists of this. SMTP with port 25, SSL on port 443. A socket is going to be a combination of the IP address, either the source or the destination, followed by a colon, and then that port number. Figure 3.15 has some good information in it. You'll see that this is a TCP packet requesting a web page from a server. The source port is going to be 1024 from the client. They're going to send it to a destination port of 80, which is HTTP, and then we'll see at the very bottom we've got the GET command. Now, we talked about this when we were talking about the proxy firewalls, because they will actually look at the application layer and see what command is taking place. And this is what it's going to be parsing. It's going to be looking, in this case, at the data to see what the application command is. A GET is to retrieve, and a lot of times that's going to be permissible. A PUT or a WRITE is something that you would expect to be filtered more. Looking at email, There are three particular protocols that you tend to use. SMTP on port 25 is used for outbound traffic, and that is going to connect to a mail server in some location and send mail out. If you're retrieving email, you can do it several different ways. The two most common ways are using POP3, which uses port 110, and IMAP, which uses port 143. The difference between the two protocols is what happens to the data. In POP3, the emails are actually transferred from the host down to the client. With IMAP, the emails reside on the host and just the visual is what's sent. If you're deleting or you're copying or do anything with your emails, all of that's going to be taking place on the server and not on the local workstation. The other common application that you'll see is web hosting. And I guess my take on this in terms of a security perspective is have somebody else do your web hosting. Keep it separate from your network. Don't give people a reason to connect in to your environment. However, sometimes you've got data, internal data, that needs to be published, and the easiest way to do that is if you have a web server. Just keep in mind that anytime you have applications or things that are accessible to the public from outside, that's going to increase your security exposure. There is a section on securing web connections. Most traffic comes in on port 80, but you can use SSL, which uses port 443, and this makes sure that you've got secure sockets running. You can also use HTTPS. That makes sure that your data is encrypted. The book has a multi-page discussion of different web add-ins that can cause problems in terms of security. And I'm not going to go through each one of these. I will say that it's a best practice to either disable or at least prompt the user when any of these methods are needed. I know that ActiveX is something that you'll see a lot, especially from Microsoft. I think this is one of the more common dangers these days. So I would make sure that your group policies are set to at least prompt the user so that they're asked if they want to install a particular piece of software. The same thing goes with Java applets and scripts. The last type of software in this particular section is SMTP Relay. And I mentioned this earlier. You can get malware or viruses on a workstation that will then send out spam or emails. Your ISP can notice how much email traffic is coming out of your particular location. And if they see a big rise in email activity, they can just shut you down. I know that Blackfoot does this routinely. And then they'll call you and say, you know, we've had to shut down your internet access because looks like you've got spam, and then you need to go through and clean things up. There are ways that you can configure your router or your firewall to prevent this. And then another thing that you'll need to do if you are hosting your own email and you've got your own email server is to make sure that it is hardened so that it will not relay information for people outside of your domain. This used to be a problem 10 years ago, and you don't see it so much now because most of the defaults make sure that you don't have an open relay, but it's just something to keep in mind. Once you are found to be relaying information, or that you're found that you have an open relay, then your IP address will end up on a blacklist somewhere. Many mail servers subscribe to blacklists, and they won't permit or accept traffic from anybody who is on a blacklisted site. That can really impact your business communications. So it's a good idea to be proactive and make sure that you remain off of these exclusion lists.